Good morning, everyone. Today we are going to start a new chapter, which is current electricity. Now, in the previous chapter, whatever charges we have seen and we have assumed they are all at rest, right? Now, whenever the charges are in motion, they constitute an electric current. So, how do you measure it? So, for that, just consider any conductor or whatever. Okay, so this is some conductor. Consider any area of cross section. So, this is the area of cross section. Suppose after every time interval t, there is a net flow of charges, say in this direction. Net flow of charges in this direction, say the amount of charge is q. So you can say in every time t, q amount of charge is flowing from left to right. So the current will be here I equals to q by t. Now here, if after every time t the amount of charge is same q, this type of current is steady current. Now it is not always possible to have a steady current, so sometimes we take small time interval and we write it in differential form like dq/dt, and you already know the unit of current is ampere. Or in capital A. Now we said that the movement of charges produces electric current, but if the movement is random, it may not always produce electric current. That we will discuss later. So to move the charges or to get a current, we need to apply steady potential difference. So how do we generally provide that potential difference? Generally we connect some conductor across any battery. For simple example, so say this is your conductor, so we connect some battery. Its voltage, for simplicity, say its voltage is V. So this is how we connect battery and produce some electricity. Now here in this case, as you already know, the direction of current is in this direction, from positive terminal to the negative terminal outside the battery. Now if the potential difference across the conductor or say wire is V, and if the current through it is I, they are actually proportional to each other, and this law is known as Ohm's law. So Ohm's law, the mathematical form is V proportional to I. To make it equation, we multiply the right hand side with a constant R, and it becomes V equals to R. Here R is called resistance. Resistance of what? Resistance of this material or wire. The resistance is property of this material. It depends on its shape, size, and also the material it is made of. And it is found that the resistance for a given wire is proportional to its length and inversely proportional to its area of cross section. And so you can write R proportional to L by A, where L is the length of the wire and A is the area of cross section of the wire. So if this is L length and this area is say A, so you can write this. Now to equate it, we multiply with another constant. This notation is called rho. This is resistivity. We can easily define resistivity from this equation. Now the resistivity is actually a constant which is different for different material. We'll discuss about resistivity later. Now you can easily define resistivity for a given wire. If L is 1 and A is 1, so you can write R equals to rho. That means the resistance of a wire having unit length and unit area of cross section is called its resistivity. And if you see its unit will be something like ohm centimeter or ohm meter, and its reciprocal is known as conductivity, which is noted as sigma. Now if you put the value of R in Ohm's law, that is V equals to IR, you can write V equals to I into rho L by A. Now since we have applied a potential difference through a battery, there will be an electric field also. If the potential difference between the ending of the wire is V, then the electric field can be written as E equals to V into V divided by L, where L is the length of the wire. So you can write V equals to EL. So just put the value here. So you can write EL equals to I by A into rho L. Now here we will introduce another term, current density, which is I by A. So here L and L will cancel out, so you can write E equals to J into rho, where J is I by A, called current density. And if you write this in terms of conductivity, you can write E equals to J divided by sigma, or J equals to sigma E. Now here current density is actually a vector quantity, and electric field is also a vector quantity. So if you write in vector form, you can write J equals to sigma E. Now, so this is nothing but the vector form of Ohm's law. We started from here and we reached here. So this is vector form of Ohm's law. Now we'll have to find conductivity or resistivity, whatever, either of it or both. You have to find a formula for it. Okay, how it is, how they are related, some other terms. We'll find that out. So in order to find resistivity or conductivity formula, okay, we'll go through some basic concepts. Suppose for example, consider just a conductor. Now in conductor, we know there is a lot of free electrons. These free electrons actually move randomly and collide with the iron cores. So though there is a movement of the electrons, but there is no current, no net current. It's because if we consider any given area, some electron is moving like this, some like this, some like this, some like this, so random. So if you consider any given area, the net charge crossing this area is actually zero. In other words, if you can write as the average velocity of the all the electrons, suppose there are n number of electrons, so the average velocity can be written as, this is just a notation, I equals to 1 to n, this becomes actually 0. So this is why there is actually, though there is a movement of the electrons, but it does not produce any electricity. Now suppose we apply some potential difference across the conductors V, which results in an electric field E inside it, right? Now with the application of this electric field, now the electrons will feel some electric force. which is equal to Fe equals to, we know F equals to QE. Here the electron charge is negative, so we can write minus E into E. So with this force they will have an acceleration, which can be written as A equals to force divided by mass. So they will be accelerated like this, and since it is negative, so they will be actually accelerated opposite to the electric field. So with the introduction of the electric field in this direction, the electrons will start moving in this direction. Now let us consider the motion of a particular electron, say the ith electron. There are numerous number of electrons. Suppose the electron collides with some iron core, and just after collision its velocity is say vi, small vi, and it is being accelerated like this. So after time t, the velocity of this ith electron will be say vi equals to, try to remember the motion in straight line equation, e minus e by m for this, say right ti, and say after this time this will again collide with something, so it is actually being accelerated for the time ti. Now this is for a single electron. Now if we consider all the electrons in the conductor, we have to take average of this. So this is the time it collides with the one, then it keeps on accelerating, then again it collides. So this is actually the time interval between two collisions for this particular electron. Now if we consider all the electrons, some will take less time, some will take more time. It is denoted by tau. See, if we take all the electrons and take average of it, we will get average now. This is just at the starting point after the collision, the average velocity of the electron. Now this is definitely 0, because just after collision different electrons will move in different directions, resulting in average velocity 0. And this velocity, the average velocity between the collisions with which the electron moves, is called the drift velocity. It is represented as Vp. And this time average already discussed, less than time, so you can write Vt equals to minus E by m into tau. So this is the expression of drift velocity. Now let us find out how drift velocity and the electric current are related. Now if you just take the magnitude, you can write Vt equals to Em by tau, just taking the magnitude. Now let us find out the relation between current and drift velocity. For that, consider a conductor of area of cross section A. Now current is defined as I equals to Q by T, or the amount of charge flows through any area of cross section in unit time, or in 1 second. So if the velocity, rate velocity is Vd, that means the electrons actually move Vd distance in 1 second. So now consider one area here. So the electric field is in this direction, and from here we take another area cross section which are Vd distance apart. So actually this is the distance any electron covers in 1 second. So now we want to find out the amount of charge crosses this area in 1 second. Now you can see the electrons who are at a distance Vd from this area will cross this, will just cross this in 1 second. Now the electrons that are here, they will go Vd distance like this, they will not be able to cross it. So any electron which is inside this volume will cross it in 1 second. So in 1 second, the total number of electrons present in this volume will cross. Now if the area of cross section is A and this distance is Vd, the volume of this is A into Vd. Now assume that in unit volume there are small n number of electrons. So the total number of electrons inside this is NaVd. D is in suffix. So if one electron has E charge, the total charge inside it is Q equals to ENaVd. So this is the amount of charge that crosses this in 1 second. So we can write it, this is as current. So I equals to, you can write NeAVd. So this is the relation between current and drift velocity. Now we have to find the formula of resistivity or conductivity. So what we will do, we will put the value of drift velocity here, just the magnitude. So you can write I equals to NEA, this is EEM by tau, by M into tau. Now we can write I equals to J into A, equals to N to E square, A E tau by M. A cancels. We can write J equals to sigma E. So sigma equals to N square E tau by M. So E cancels, so you can write sigma equals to N square tau by M, or resistivity rho equals to M by N square tau. So these are the formula of conductivity or resistivity. So you can see resistivity actually depends on mass of the electrons. In any conductor this is same, the number density is almost same, the charge of electron, and this is the relaxation time, which is different for different material. And this relaxation time is also dependent on temperature. So the conductivity or resistivity also depends on the temperature. So this is it for today. Tomorrow we will discuss about the resistivity and some drawbacks of Ohm's law, etc.